So the problem, as stated on Wyzant, was that we had a function defined as x cubed minus 3 over g of x, and we were supposed to find a function g of x so that the rational function f of x, which equaled this, had a slant asymptote at y equals x with no vertical asymptotes. Usually Wyzant puts the question on the board as it prepares these videos. I'm not sure why that didn't happen this time. Okay, now just for the heck of it, let's let g of x equal x squared and see what happens. So in that case, we'd have f of x equals x cubed minus 3 over x squared. And the key is to recognize the slant asymptote is to actually use long polynomial division and rewrite the way this looks. So I'd have to leave placeholders in here for x squared and x, possibly. But x squared goes into x cubed x times x squared is x cubed. Subtract, get a 0, bring down the next term, and that's your remainder. So I can rewrite f of x as x minus 3 all over x squared. And the key is, what happens to f of x as x gets really big? For example, what's f of 100? Well, it would equal 100 minus 3 over 100 squared. So this term right here approaches 0 as x gets large. But it's never going to equal 0. But since I have a minus sign here, it's always going to be a little less than 100. So I'm getting really closer and closer to f of 100 equals 100. Since the problem says no vertical asymptotes, we have to adjust this denominator because there is a vertical asymptote at x equals 0 because f of 0 is undefined. So we could probably maybe like put a minus 1 here. Well, that won't work because then we'll introduce vertical asymptotes at 1 and negative 1. But if I put a plus 1 here, there will be no vertical asymptotes because the denominator is defined for all values of x. So let's go to Desmos so you can see exactly what this looks like. So here is, well, here is, I used k instead of f. But here, when the denominator is x squared, there is a vertical asymptote at 0. You can't see it here, but if I scroll way down, you'd see that the red graph is getting closer and closer to 0. If I put a minus 1 in here, then there are vertical asymptotes at 1 and negative 1. But if I put a plus 1 in here, or 2 or 3 or whatever you want, there's what the function looks like. And since I can rewrite it as we saw, oh, this isn't the same problem. Okay, so the graph is always under the line y equals x, but it's getting closer and closer. So you might want to try long division of x squared plus 1 into x cubed minus 3. As a matter of fact, let me do that. So x squared plus 1 divided into x cubed minus 3 is, as long as the denominator is 1 less than the degree of the numerator, you're going to have a slant asymptote. So x cubed plus x. If I subtract, I'll get minus x minus 3. So I can rewrite f of x in this case as x minus, let me put a plus right here, minus x minus 3 over x squared plus 1. And since this term is approaching 0 because the degree of the denominator is greater than the degree of the numerator, that's it. I'm supposed to stop recording because I'm over 5 minutes. But just one quick thing. If I put a 3 here, that is going to change the slant asymptote to y equals 1/3 x. And you can try.